welcome to Akshar Academy YouTube channel. In this session, I am going to discuss class 9, chapter 4, refraction of light at plane surfaces, improve your learning, reflection of concepts, question and answers, AP and TS boards. If you like this video, please like, share and subscribe to our channel. Please share your valuable comments in the comment section. Okay, let us go to the today's session. First question. The speed of light in a diamond is 1,24,000 km per second. Find the refractive index of diamond if the speed of light in air is 3 lakhs km per second. Now, here in this question, we have to calculate speed of light of diamond they given and the speed of light in air they given, and we have to calculate refractive index of diamond. Let us go to the solution. Given speed of light in diamond is equals to speed of light in diamond is equals to 1,24,000 kilometers per second, and speed of light in air they given as speed of light in air is equals to 3 lakhs kilometer per second. Now we have to calculate refractive index. Refractive index is equals to speed of light in air by speed of light in diamond. Speed of light in air they given as 3 lakhs kilometer per second, and speed of light in diamond they given as 1,24,000. Refractive index is equals to speed of light in air or vacuum by speed of light in medium. So here 0, 0, 0, 0, 0, 0 gets cancels. We are getting 300 by 1.04. This is equals to, we are getting 2.42. This is the refractive index of diamond. So the diamond has the highest refractive index. The value is highest. So refractive index of diamond is equals to 2.42. So therefore refractive index is equals to, we are getting 2.42. Okay, next we will go to the next question. In this question they given refractive index of glass relative to water is 9/8. We have to calculate refractive index of water relative to glass. Let us go to the solution. Given relative refractive index of glass, relative refractive index of glass to water, relative refractive index of glass to water they given as 9/8. Refractive index of water relative to glass, that is 1/9/8. Refractive reciprocal. Refractive index of water relative to glass is equals to 1/9/8, that is equals to 8 by 9. This is the answer. Okay. Next, we'll go to the next question. The absolute refractive index of water is 4 by 3. What is the critical angle? Here in this question, they given absolute refractive index of water. We have to calculate a critical angle. Now let us go to the solution. Absolute refractive index of water is equals to, given absolute refractive index of water is equals to 4 by 3. The relation between critical angle and the refractive index is sin C is equals to 1 by mu. Mu nothing but refractive index. So, sin C is equals to 1 by 4 by 3. So, that implies here sin C is equals to reciprocal 3 by 4, that is equals to 0.75. So, sin C is equals to we are getting 0.75. So, this implies C is equals to sin inverse of 0.75. This value is equals to 48 degrees 5. So, 48.5 degrees. So, total we are writing critical angle of water C is equals to critical angle of water critical angle of water C is equals to, we are getting 48.5 degrees. This is the final answer. Okay. Next we will go to the next question. Determine the refractive index of benzene if the critical angle of benzene is with respect to air is 442 degrees. This is 42 degrees. Now we have to calculate the refractive index of benzene. Okay, they given as critical angle of benzene is 42 degrees. Okay, now let us go to the solution. Given critical angle of benzene is equals to critical angle of benzene, that is equals to, they given as 42 degrees. So, the relation between refractive index and critical angle, that is equals to sin C is equals to 1 by refractive index. So, this refractive index we have to calculate. So, or sin C is equals to 1 by mu. So, C, substituting the value of critical angle here, sin 42 degrees is equals to 1 by mu. So, mu is equals to refractive index of benzene is equals to 1 by sin 42 degrees. So, sin 42 degrees value 0.6691. This is equals to 1.49. So, refractive index of benzene is, therefore, refractive index of benzene is equals to 1.49. Okay. Next, we will go to the next question. In this question, explain the formation of mirage. Now, let us discuss formation of mirage. Actually, mirage nothing but mirage is an optical illusion. What is a mirage? Mirage is an optical illusion. When you are going for a long distance, here you are assuming that there is a water for a long distance, but if you want to collect that water, there is no water. That is the optical illusion. Now we'll discuss in detail. Formation of mirage. When the light from tall objects such as tree or from the sky passes through a medium just above the road, then the refractive index of light decreases towards the ground. Here towards ground. So if it undergoes refraction and takes a curved path because of total internal reflection. First point, now the light is coming from the tall objects. We are taking for example tree, and from the sky passes through a medium just above the road. Then what will happen? Refractive index decreases. So it undergoes refraction and takes a curved path because of total internal reflection. In total internal reflection, the light ray never enters the radar medium, and again it enters the same medium. So next point. In this, when this light reaches the observer, then it appears as if it is reflected from the ground. So here when the light reaches the observer, then it appears as if it is reflected from the ground. So next, hence we feel the illusion of water being present on the road, which is a virtual image. Actually there is no water. Because of refraction and because of total internal reflection, we are assuming that there is a presence of water. But if we want to collect the water, then there is no water. That is known as the optical illusion. Such virtual images in the sky called the mirage. Let us see this diagram. This is refractive index decreases with the depth. Now we are taking the tall objects. Here it is the presence of water. If we want to collect that water, there is no water. So hence we feel the illusion of water being present on the road, which is virtual image of the sky called the mirage. Mirage is an simple one, optical illusion. Okay, next we'll go to the next. Explain the refraction of light through a glass slab with a neat ray diagram. So in this question they are asking that we have to explain the refraction of light through a glass slab with a neat ray diagram. Now let us discuss the experimental part. First, aim. Determination of position and nature of image formed by a glass slab. Materials required: blank, chart paper, clamp, scale, pencil, thin glass slab and pins. First procedure: place a piece of chart on a plank, clamp in it. Place a glass slab in the middle of the paper. Draw border lines around the edges of the slab by using a pencil and remove it. You will get a figure of a rectangle. Next, name the vertices of a rectangle A, B, C and D. Draw a perpendicular at a point on the longer side of the rectangle. Now draw a line from the point of intersection where side AB of a rectangle and perpendicular meet in such a way that it makes an angle 30 degrees with the normal. This line represents incident ray falling on the slab, and the angle it makes with the normal represents angle of incidence. Now here in this after formation of rectangle, here we are noting the vertices, that is A, B, C and D. After that we are drawing the perpendicular line on the longer side of the rectangle, and after that draw a line from the point of intersection where side AB of the rectangle and perpendicular meet. Here we are drawing the line and then it makes an angle 30 degrees. Here this is the angle of incidence. Angle of incidence nothing but the angle between incident ray and the normal is known as angle of incidence. This line represents the incident ray and angle makes with the normal, and the incident ray is known as angle of incidence. Now for example, here we are taking angle of incidence is equals to 30 degrees, and then next, now place slab on the paper in such a way that it fits in rectangle drawn. Fix two identical pins on the line making 30 degrees angle with the normal such that they stand vertically with the same height. By looking at the two pins from the other side of the slab, fix two pins in such a way that all pins appears to be a straight line. Remove the slab and take out the pins. Draw a straight line by joining the dots formed by the pin up to the edge CD of the rectangle. This line represents emergent ray of the light. Now we are taking the slab and we are placing the slab on the paper, and take two identical pins and making an angle 30 degrees. We have to place two pins vertically, and by looking the two pins from the other side of this slab, fix two more pins on the other side of this slab, and it forms a straight line. Now we have to remove the slab and we have to take out the pins and draw a straight line. This line represents the emergent ray of the light. Next, draw a perpendicular to the line CD where our last line drawn meets the line CD. Measure the angle between emergent ray and normal. This is called angle of emergence. The angle of incidence and the angle of emergence are equal. Incident emergent rays are parallel. The distance between parallel rays is called shift. Here, after drawing the line CD, we have to measure the angle between emergent ray and normal. This is called the angle of emergence. So, the angle of incidence and the angle of emergence are equal. Now, incident ray, and now we are extending the incident ray, extended incident ray and emergent rays are parallel. So, this distance between parallel rays are called shift. This is also known as lateral shift. Next, see this figure. Now, first we have to place a piece of chart on a blank, clamp it, place a glass slab in the middle of the paper, and we have to draw the border line along the edges of this glass slab by using pencil and remove it, and then you will get a figure of rectangle. Now this is the rectangle. Now we are labeling the rectangle like a vertices. These are the vertices A, B, C, D. This is the our rectangle glass slab. Next, we have to draw a perpendicular line, that is normal, on the longer side of this rectangle. Now here we are taking AB. Now this is the perpendicular line, that is normal, and we are drawing the normal on the one side of this rectangle, that is here we are drawing the normal on AB, and then taking the line which makes an angle 30 degrees. Here we are taking the angle of incidence, that is in this we are taking this angle, drawing this line and making an angle 30 degrees. This is example, and this is the incident ray and this is the normal, and incident ray angle between incident ray and normal is known as angle of incidence. That is, the letter indicates I. I denotes the angle of incidence. And now we are placing this glass slab into this border line ABCD, and then Here now we have to place the two pins on this incident ray. This is the arrow mark indicates the direction of the incident ray. Now we have to observe the image of the two pins on the other side of the rectangle. This is the from CD. Here this is the image of the eye. From this direction we are observing the image of these two pins, and we have to place the two pins on the other side of this rectangle, that is the side CD. Now we have to join these two dots. This is the line represents emergent ray. Here the light ray traveling from initially from rarer to denser, this is the refractor ray, move towards the normal. This is the angle of refraction. And then now the light ray is traveling from glass medium to rarer medium, that is denser to rarer. Now whenever the light ray traveling from denser medium to rarer medium, the refractor ray move away from the normal. This is the refractor ray moves away from the normal. So now here we are drawing the normal, that is a perpendicular line, and this is the emergence, that is emergent ray. So the angle between emergent ray and this normal is known as angle of emergence. Here we are taking this also I. So now here angle of emergence and angle of incidence are equal. Actually this is the ray without any deviations. This is the path of this ray. Whenever we are extending this ray, these two rays are parallel rays. This is the distance between these two rays is known as shift, that is lateral shift. So this angle of incidence is equals to angle of emergence. So incident ray, whenever we are extending the incident ray and emergent ray, these two are parallel to each other. They never intersect. The angle between them is 0. So the distance between incident ray and emergent ray is known as lateral shift. Okay, this is about the lateral shift. The distance between the parallel rays is called shift. Okay, next we will go to the next question. Why do stars appear twinkling? Now we will discuss why the stars are appear twinkling. The twinkling of star is due to atmospheric refraction. Due to atmospheric refraction of starlight, the stars are twinkling. So the starlight on entering the Earth's atmosphere undergoes refraction continuously before it reaches the Earth. The atmosphere refraction occurs in a medium of gradually changing refractive index. So since atmosphere bend starlight towards the normal, the apparent position of the star is slightly different from its actual position. So now next, stars appear slightly higher than its actual position when we viewed near the horizon. So further, their apparent position of the star is not stationary but the position of the star is keep changing slightly. So why? Because physical conditions of Earth atmosphere are not stationary. So that's why, since the stars are very distant, they approximate point size source of light. They are very distant, so that's why the size of these stars are very point sized. So as a part of rays of light coming from the star goes on varying slightly, the apparent position of the stars fluctuates and the amount of starlight entering the eye flickers. So stars sometimes appears brighter and some other time fainter, which is the twinkling effect. So this is about the stars appear twinkling. Okay, thanks for watching this video.